Okay, guys. So this is our. Inshallah, this is will be the last. Yeah, lesson via this kind of video. Yeah, guys. Hope that next week I can come to school, so we can have a lesson together. So at the last time, guys, we already learned about the differentiation, right? A little bit about, yeah, we didn't start the differentiation, but we already done the prerequisite knowledge, which is this one. And also we already talk about why do we study differentiation as well, right? Now we're gonna start to the subtopic 7.1, which is derivatives and gradient function. Okay, so we will learn about the, yeah, the correlation between the derivative and the gradient function. So if you remember at the IGCSE curriculum, you learn that when you want to estimate the gradient of a curve by a point by drawing suitable tangent and then calculating the gradient of the tangent. Now, this method only give you an approximate answer, right? Now, because an accuracy of a drawing of a tangent and also very time consuming, right? But in this chapter, we're gonna learn how to find the exact gradient of the graph of the function. We don't need to draw the graph, okay? And the exact method, this exact method is called by differentiation, okay, guys? Now, so for example, here we have the general formula for the gradient for the curve y equal to x squared at the point of x, point x squared can be proved algebraically. Okay, how? So let's say we have this curve. Okay, guys, so this is the curve, and let's take one point, the p point, x and y, on the curve of y equal to x. So the p is over here, and point A that close to the P point. Just imagine that the A and P are very close. Okay, guys. But yeah, we can because we need to draw this, so we saw it like it's very far away, but actually this is very close. Okay, guys. Okay, so this is the point A and this is the point P. Okay, the point P is the x point y, and this is the A. Okay, on the graph of x squared. Okay, now so when we draw a triangle here, we can see that the point of the A and the P, yeah, guys, yeah. So the distance from A to P, we call, for the y we call is delta y, and for the x is we call as the delta x. Okay, guys, so the coordinate of A, before we know that the P is x point y, right? But the A is x plus delta x, and the y point of the A is y plus delta y. Okay, where delta x a small increase in the value of x, and delta y is corresponding small increase in the value of y. Okay, guys, understand until here? Okay, so we can also write the coordinate of P and A as, so this is the P was x point y, right? But because y equal to x squared, so we can write the y here, substitute the y here by x squared. Okay, so the point of P is x point x squared, while the point of A is x plus delta y. And because, yeah, the y equal to x squared, so we can also substitute the y over here by y plus delta x squared, right? Now, because we want to find the gradient, so we can write the gradient like this, right? So the gradient of the chord of PA is delta y minus delta x, or we can also write like the distance, yeah, distance between y over the distance between x, right? Okay, so because we minus it from the A, right? So the A, the point of y of the A minus the point y of the P, and this is also same, yeah, guys, yeah, the point of x of the a minus the point of x of the p, right? Okay, so because the y is x plus delta x squared, so we can expand the quadratic, right? So to expand the quadratic, so yeah, just use the formula of a squared plus 2ab plus b squared, yeah. So we got x squared plus 2 times x times delta x, right, plus delta x squared minus x squared, just write it as minus x squared, and because it's x plus delta x minus x, so we can cancel the x, so the denominator we only have delta x. Okay guys, and here also we have x squared minus x squared, so we can cancel the x squared as well, right? And we just got the 2x d delta x plus delta x squared over delta x, and then we canceling the delta x here because it's a square, so we can only cancel one of the delta x from the second terms, so we got 2x plus delta x at the end. Okay, now here it says that as delta x tends towards 0, because it's very close, I've told you, right guys, that a and p are so close, that why the delta x tends towards 0, that why a tend to be of the gradient of the chord PA tends to the value, we call the value of the gradient of the curve at the P, in this case before the gradient of the curve of P is 2x. Okay, so we can say that because it's tend towards 0, so we can say that the gradient is 2x. Okay guys, now okay, so the process of finding gradient of a curve at any point is called differentiation. So yeah, this kind of things, finding the gradient of the curve in any point called as differentiation. Okay guys, so later in this chapter you will learn some rule for differentiating function without having to calculate the gradient of the chord as we have done. So later on we don't need to do like this guys. Okay, so we just show you how to find the gradient using this kind of thing. Okay, the process of calculating gradient using limit of gradient, of course, sometimes called differentiation from the first principle. So this is the first principle of the differentiation itself. Okay guys, now we're gonna learn about the notation of the derivative itself, yeah, differentiation itself. So there are three different notation that used to describe the previous rule. Okay, so if we have y equal to x squared, just like the curve that we had before, yeah, then we show the derivative as dy over dx. So this is the first notation of the derivative is dy over dx. Okay, so dy over dx is the first notation of the differentiation. And the second one, if fx equal to x squared, then f prime f with one, yeah, like what do you call for this, like, yeah, prime, right, prime x is equal to 2x. So this is also the notation of the differentiation. This is the second notation of differentiation. And the last one is d, and then you write bracket x squared over dx, or also like this, d over dx, and then bracket x squared. This is also showing the differentiation. Okay guys, so there are three notation of differentiation. The first one is dy over dx, the second one is using prime, okay, so showing the function and put the prime on the function. It's different with the inverse. Okay guys, if the inverse, it will use -1, right, but this is only like, yeah, tanda petik kayak gitu ya. So it's f prime. It's also showing that is a differentiation. And the last one is d and then over dx and then bracket the function directly. Okay, that also the notation of derivative. So if the y is a function of x, then dy over dx is called derivative of y with the respect to x. Okay, so dy over dx is called as the derivative of y with the respect to x. Likewise, f prime x is called the derivative of fx. Okay, if y equal to fx, the graph of the function, then dy of the dx or f prime x is sometimes called as the gradient function of the curve. So yeah, the gradient function means the derivative also. Okay guys, and the last one, the d over dx bracket x square equal to x, means that if we differentiate x square with the respect to x, the result is 2x. Okay, something like that. You don't need to be able to differentiate from the first principle, but you are expected to understand that the gradient of the curve at a point is a limit of the suitable sequence of the curve. Okay, now here it is guys. How to differentiate, we come to the rule. Okay guys, differentiation of power function. Okay, so we learn, right, that the d over dx of x squared was 2x, right, and that d over dx x cubed is 3x squared. Now, investigating gradient of the curve y equal to x to the power of 4, y equal to x to the 5, the power of the 5, and y to the power of y equal to x to the power of 6 would give the result like this guys. Okay, so for the x to the power of 4 will give you 4x cubed. For the d over dx x to the power of 5 will give you 5x to the power of 4, and for the x to the power of 6 is 6x to the power of 5. So you can see the difference over here, right? You can generalize the formula for differentiation. So if you notice guys, so the power of the function always come down, right? Come down, and then the power will be subtracted by 1, right? It's always like that, right? So that's why d over dx x to the power of n will be like this guys. So n is the power of n of the x, right? Previously will come down, so n times x and then minus 1 the power, so x to the power of n minus 1. Okay, this is true for any real power n, not only for positive integer values of n. So even the power is negative or maybe fraction, so we can apply this formula. Okay guys, you may find it easier to remember this rule as multiply by the power of n, then subtract 1 from the power. Okay guys, yeah, this is what I've told you, right? Okay, this is for differentiation. Okay, so for the earlier example where x equal to y equal to x squared, so yeah, multiply by the power because the power was 2, so 2 times x, you minus 1 the power, so you got 1. So that's why the differentiation of x squared was 2x. Okay guys, okay, let's do the work example 7.1 together. So find the derivative of the each following. The first one is x to the power of 7, so d over dx of x to the power of 7 will be like, put down the power guys, so it will be 7 times x minus the power by 1, so it will be 6, right? There it is. Okay, so for the b1, because yeah, this is the powers cannot be on the denominator, so you should put it up, put the power, make the power negative first. Okay guys, so it's x negative 2, right? X to the power of negative 2, so the differentiation of x to the power of negative 2 will be, put down the power which is negative 2 times x and then minus 1 the power, so minus 2 minus 1 will be minus 3, right? So you can also write it as the fraction again, so it will be negative 2 over x cubed. Okay, Next one, so the fx is square root of x, so you need to change it into a power again. So what is it? Square root of x will be x to the power of 1 over 2, right? So what is f prime x then? So put down the power once again, so it's a half, right? Times x, so a half minus 1 will be negative 1 over 2, right? So you can also write it as a as a fraction again, so it will be like this, right? Okay, and the last one, y equal to 2. So what is the dy, sorry, yeah, over dx? Yeah, because it doesn't have x, yeah, because we differentiate it to the respect of x, but then the number doesn't have x, so the differentiation will be 0. Okay, so the differentiation of the constant will be you always equal to 0. Okay guys, remember that. Okay, now you need to know and be able to use the following two rules as well, guys. So the first one is the scalar multiple rule. So if the k is the constant and the f is the function, then so the differentiation of the k times function equal to k times the differentiation of the fx. So you just like ignore the k, so because the k is a constant, guys, so it doesn't affect. So k times function, you just don't differentiate the k, instead you just differentiate the function, but remember to multiply the final answer by the k, so the k still stand there. Okay, and the next one is the addition or subtraction rule. So if the fx and gx are function, then d over dx of fx plus or minus gx, so it will be like differentiation of the fx itself plus or minus differentiation of the gx. Okay, so you just need to differentiate each of the function. Okay, so it doesn't affect actually. Okay, so for example 7.2, differentiate 3x to the power of 4. Now minus blah 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 with the respect to x. So guys, we have 3 here, right? So for this 3, it's actually like k. So remember guys, the scalar multiple rules. So we need to find the derivative of the fx to the k, right? So just treat the 3 as the k. So because we want to put down, okay, let me write it first. So 3 still be there, and the 4 will going down, so 4 times x, 4 minus 1 will be 3, right? So that is the differentiation. But okay, let me, because it's not on the power yet, so let me write it's 3x to the power of 4 minus 1 over 2 x to the power of minus 2, right, plus 4 x to the power of negative 1 over 2 plus 5, right? This is the function. Okay, let's differentiate one by one. So we already differentiate the first term, so let's differentiate the second term. So just write 1 over 2, negative 1 over 2 there, and then just differentiate. Okay, so the first one only differentiate this, so only differentiates the one with x. Okay guys, so if you have a number over there, so just put it there. So times negative 2, right, negative 2, and then x, negative 2 minus 1 will be minus 3, plus 4 times negative 1 over 2 times x, negative 1 over 2 minus 1 will be negative 3 out of 2, right, plus, because 5 doesn't have x, so the differentiation of 5 will be 0. Okay, now let's multiply the number. So 3 times 4 will be 12, right, 12x cubed, and then negative 1 over 2 times negative 2, so it will be plus 1, right? 1, we don't need to write coefficient of 1, so it's only x to the power of minus 3 plus 4 times negative 1 over 2, so we cancel it, so it will be negative 2, right? X to the power of negative 3 out of 2 plus 0. We don't need to write it. If you want to make it a fraction again, so we can write like this, because it's x to the power of minus 3, so it will be 1 over x cubed, like this, right? Minus 2 over x to the power of 3, and then being squared, right? Like that, guys. Okay, so that is how to differentiate this kind of function. Okay, let's move to the work example 3.7.3. Find the gradient of the tangent to the curve, this at the point 1.4. Okay, so we are finding the gradient of the tangent without what we used to do, right? Like finding 2 point and then finding the distance, something like that. So we just gonna differentiate this. Okay, guys. Now actually, from the addition and the subtracting rule, when we are differentiate a function, we directly differentiate it, right, guys? But this is addition and subtraction. Okay, what about if it's multiplication like this, guys? So if it's multiplication like this, so you cannot differentiate directly like one by one, like differentiate the x itself and then 2x minus 1 itself and x plus 3 itself. But remember, you need to multiply everything first until it become subtraction and addition, and then you can differentiate it. Okay, guys, so let's multiply the y first. Okay, change the y. Okay, so I will put the x outside first and then multiply this, yeah, first. Okay, so 2x times x will be 2x squared, right? And then 2x times 3 will be 6x negative x negative 3, right? Then x will be 2x squared plus 5x minus 3, and then multiply everything by x, so it will be 2x cubed plus 5x squared negative 3x. That is the y. Okay, now so we got the y, so we can to find the gradient of the tangent, so the gradient will be the derivative. Okay, so let's find the dy over dx from the y here. So it will be 2 times 3. Okay, I will write it first, x to the power of 2, or if you want we can directly multiply. Okay, so 2 times 3 will be 6, right? X squared. Okay, plus 2 times 5 or 5 times 2 will be 10, right? And then minus the power by 1, 2 minus 1 will be x only, right? X to the power of 1. And if you have minus 3x, the differentiation will be the coefficient itself, so only negative 3, because what? Because 1 going down, it will be negative 3 times 1 is negative 3 itself, and x to the power of 0, right, it will be 1. So only write the number or the coefficient of the number if you have x. Okay, guys, so this is the dy over dx, because it's asking you the tangent at the point 1.4, so we can put the x. Okay, guys, we have the x. Okay, like because it's the point 1.4, so substitute the x by 1. Okay, so 6 times 1 square plus 10 times 1 minus 3. So this we gonna be the m, or the gradient. Okay, so 6 plus 10 minus 3, right? So it will be 13. So the gradient will be 13. Okay, gradient is 13. Okay, that it is, guys. Okay, so please you do, I think we don't need to do the question number 1. Number 2 also very easy. I think please do question number 3. Okay, guys, and then Number 4, yeah, it's a lot, but they are easy. Number 5, okay, maybe just number 5 is not all of them, yeah. Maybe we start from 3, right? 3 is quite good. So for number 5, yeah, just do all of them, it's okay. And then please do number 7 as well, okay? Number 7. Okay guys, so this is what you need to do in the class, okay? So do number 3, 4, 5, and 7, okay guys? That it is for today, okay? Thank you guys, and see you next week.